Hello everyone and welcome to our new video. In this we are going to continue on the distroless images, and we are going to see the next aspect where we are told that the distroless images are more secure, they have less surface of vulnerability, they are smaller in size, and if they don't have the package manager or the bash, and this allows the distroless to use the have the smaller size. At the same time they are more secure because the vulnerabilities are less. So let's verify this, and this video is like in continuation. We have created two other parts where we, in the first part we have discussed about the setup of the system and downloading the distroless image. In the second part we actually created the application using the distroless, and we basically created three images and we do a comparison on the basis of size, which of the image is best and which strategy you can opt for. Now, in this third part, we are going to discuss about the vulnerabilities of these three images which we have created. The first one is the distroless, which we have created through the distroless image of the node, and then we, in the second we have created without the multi-stage build, in which we use the distribution based node image, and the third one was the node image based on the Alpine Linux. So these are the three of the images which we are having. So now we are going to analyze them from the vulnerability aspect. So let's clear this. And if you want to analyze your images, so very first thing that you need to do is you need to push them inside your Docker, like Docker registry, that is hub.docker.com. So you can say Docker login, and it's going to ask you for the username. So you can put your username and the password. So once you have succeeded, you will need to push these images inside your Docker Hub registry. Once you push them, then you can go ahead and analyze them. So I'm going to push this. I actually tag this in the format of which becomes easier. That is my username followed by the image name. So let's push this inside the Docker registry because we are going to run the vulnerability assessment on these images. So I'm going to push this image one by one inside all the three images inside my Docker registry. All right, this has been done. Now I'm going to push my second one. Which is app without multi-stage build. So it is pushing right now. And then we are going to push this alpine based app. Okay, so these are the three images. Let this push. So I'm going to pause the video so that it can be completed quickly.
Recording in progress.
All right, at this point, the image has been pushed. So I'm now going to push the third image, which is my alpine image. Okay, alpine based application. So I'm going to push this one now, and it is pushing. Now once you push them, okay, then you can actually use the vulnerability scan which the Docker Hub or provides you. They basically provide you up to, like, I think it's 15 or 20 scans for free. So you can directly scan and look out for the vulnerability. So in our case, what we're going to do is we're going to scan the very first image, that is our distroless image that we have pushed. So we are going to scan the distroless image. It's going to take a while to print the result. Okay, it's basically relying on a third party called Snick, That's what it is asking us, the consent that they are going to provide this to Snyk for running the scan. It's like an API integration with the Snyk in the backend, which is performing the scan. So let's wait and pause our video to let the scan complete and show us the result. All right, I have run the scan now. So if you see here, I have run the Docker scan. Now you might find that there is an extra zero here. This is because my limit of Uncle 60 has reached to 10 Docker scans. That's why Docker prevented me from doing additional scans. So I tagged again with the one additional zero and pushed and scanned the image. So this is basically the same image. Okay. Now once I scan this distroless node app, I see that these are the vulnerabilities that it has scanned for. And if you scroll down from these, because here you will find that there are two main vulnerabilities that it has scanned. One is for this distroless node app, and you will find that it has scanned, and it basically within the distroless, it was able to find the vulnerabilities. So these are the vulnerabilities that it has reported in the image itself. And then within the package.json, if you look at the vulnerabilities, it has contained multiple parts. So what we are going to do is we are going to record this inside our Sublime text editor, and then we are going to analyze them side by side when we scan all. All right, at this point, I'm going to copy these vulnerabilities, which is for my distroless image inside the Sublime editor, which I'm just going to show you. And this one as well. Okay, so let's copy this for the npm. And so if you see at this point, here is my Sublime editor. So this is the very first one which we tested for the distroless. Okay, now after we have tested this, we are now going to test our another image that is we are going to test the image for the node, okay, which was the generic image and the biggest image in which we didn't use the multi-stage build. Okay, let's scan that one now. So I can go back, and I'm going to this time I'm going to scan the other image. So I can say Docker. Let's clear this one first, and I will say Docker scan the next image, that is app without multi-stage build. Okay, let's scan this out. It will take some time to scan. Right, so this one has completed now. If you take a look, it took a while and it took a significant amount of time to scan this image because this image was very big. Okay, so it has been completed now. Okay, so if I scroll down and show you the vulnerabilities, you will see there are high number of vulnerabilities which has been reported in this one, because it is using a full level of the distribution as well as the application. So if you look here, that is if you are running our application without uh, multi-stage build, and you use a full distribution, then you can clearly see how many vulnerabilities are there which has been reported inside this application. Okay, so if I just go ahead and compare it with the other one. So in the previous one, you will find that we were only having the 16 vulnerabilities. And if you look here, the number of vulnerabilities are quite high this time. And so if I now let's go ahead with the third image type, in which we basically used the alpine Linux. So now we are going to scan the third image. Okay, so let's go ahead and scan that. Just going to refresh the screen, and let's go ahead and say docker scan and put the image. Okay, so this is the image, and let me just remove this one. Okay, so now if you see, we are going to uh, scan the alpine node, alpine based app, node app, okay, image that we created. So let's go ahead and scan this, and it's going to scan the alpine based node app now. So uh, let it complete, and then we are going to compare all three of them from the vulnerability aspect. Right, so the image has been scanned. If we take a look, okay, so here we basically ran the scan, and it has completed the scan now. And if we, here is the where we run the command. Okay, so if I just copy the dependencies like the vulnerabilities for now, okay, and just verify this. So we can go ahead and put this under the Sublime editor. Okay, so all right, now we have the data from all the three images. Basically, it was the same image that we have built over the distroless link, distroless image. Okay, then we actually build this on the standard image, and without the multi-stage build pipeline and multi-stage build, and then we actually build it on the alpine based image. Okay, now if you see clearly, uh, the main of the two of the most important images to be compared is the distroless, in which we see that even though it's a distroless based on the domain image, it was still having the vulnerability. So it tested for 9 dependencies for known vulnerabilities and found that 16 vulnerabilities were there inside the distro list. Now, this is significantly lower if we compare it from the full distribution based image. So there were 546 vulnerabilities, and some of them were the highly critical as well. So again, if we compare the distroless with the full distribution based, we find that the vulnerabilities are much less in case of distroless. Now if we compare distroless with the alpine based, okay, then we found that in alpine we are not having any vulnerabilities. It was not able to detect, um, although this is somewhat contradictory because the main purpose of the distro list was to reduce the vulnerabilities, but then the number of vulnerabilities are very less, and there's one more advantage because it does not use the shell. So any shell-based command for trying to uh, uh, causing some vulnerabilities like usage will not result eventually because this is not having the shell also. So again, it has certain advantages, but saying that it's not, it's having the it's not completely secure, it still have few of the vulnerabilities which the scanner was able to detect, and this was actually detected inside this image distroless node app, while the application node app itself that we created was not having any vulnerability. So again, saying it reduces the attack surface, but then distroless is, you can think of it like an additional step which you can take for uh, making your application more secure, your image more secure by reducing the vulnerabilities. But then this is not in itself. We do not find that it's a complete solution, but definitely it has its own advantages. So combined with the others, it does provide you with a strong security for your Docker images. So that's all the for this video. And lastly, we are going to wrap up the uh, distroless images by considering why the distroless is not a complete solution in itself. Certainly, it has its advantages, but then we are going to examine that in the next video. Thank you, everyone. So if you have not subscribed to our channel, don't forget to subscribe to our channel. Thank you.